Okay guys, today we're going to be looking at adding vectors using the component method. And basically I've set up the problem here to be a displacement problem. You're going to start here and you're going to go 50 meters, 35 degrees north of east. Then you're going to go 25 meters, 20 degrees north of east. And then you're going to go 100 meters, 70 degrees south of east. And what we're going to do then is figure out how far we are away from where we started. We're going to be finding that resultant vector right there. Okay? And so how we do that is we go about breaking each of these vectors into their components. So if we look at vector A right here, it has a component right here that is going to be an x component. We can call that ax. It has an ay component. Right there, we can call that AY. Vector B, right here, which has a magnitude of 25 meters, has an x component right here, BX, and a y component right there, BY. Vector C, which has a magnitude of 100 meters, has a x component, CX, right there, and a y component, CY, right there. I think you guys would agree then if we look that if I take my AX and my BX and I add my CX, if I add all those together, that would come out to be equivalent to my RX going in that direction. Now my AY going up and my BY going up and my CY going down, if we add all those together, that would give me my resultant in the Y direction. So what we can say is we can say RX equals AX plus BX plus CX. And RY equals AY plus BY plus CY. Now, that's the gist of what we're doing. We have to go in and break each of the components down. This is good. It gets a little tough, and it gets a little, it's not really tough, it's just hard to find a place to do it. Guys, this one here, AY, or AX, I think you'd agree that we have adjacent to this angle, and that's our hypotenuse. So what we would do there is we would say, we would be using adjacent and hypotenuse, so we'd say cosine of 50 equals adjacent over hypotenuse, AX over 50. And so if we solve for that, we get AX equals cosine, cosine 35 is what we should have there, 35. We say cosine 35 times 50. Now, it's moving in the right direction, so that's a positive. So we're going to get AX is going to be, oops, I should be doing that in black. AX is going to be equal cosine 35 times 50. It's positive, so we're going to leave that positive. If we go over to the BX, guys, we're going to be in blue here. I think you'd agree that it's adjacent and hypotenuse, and so we're going to go about doing that same thing. The cosine of 20 equals BX all over 25, and so BX is going to turn out to be cosine 20 times 25. So we're going to have, and that's also going into positive, so we're going to have positive cosine 20 times 25. Now CX, you'll see here, also goes in the positive direction. So in that case, it's kind of interesting. We have adjacent and hypotenuse. So we're going to be cosine of 70 degrees equals adjacent, which is CX all over hypotenuse, which is 100. And CX is going to turn out to be cosine 70 times 100. So in this case, we're going to write in plus cosine 70 times 100. Now, if we go in the Y direction, here, guys, we go back to this, we're going to be looking here, and this is positive because it's going upward, and that's going to be the opposite, so we're going to say sine of 35 equals opposite, AY, all over the hypotenuse, which is 50. And we're going to solve that. We come up with AY equals sine 35 times 50. Okay, so we come back here. It's a positive, so we're going to plug that in. We're going to say sine 35 times 50. Now by, if we look at by, going back to the blue marker here, by is going to be a little bit hard to find the space for, so let's write it up here. It's opposite and hypotenuse, so we're going to come in and go sine of 20 equals opposite, which is by, over hypotenuse, which is 25. We're going to come up with by equals sine 20 times 25. Notice it's moving upward, so that's going to be positive, so we'll come back and we'll write that in here as positive sine of 20 times 25. And then we're going to go to the very last piece here, and the addition is this vector is moving in that direction. So because it's moving down, we're going to call that a negative direction, and we're going to have, to find CY, we're going to set it up where we have opposite. This is the opposite side and hypotenuse, so we're going to say sine 70 equals opposite CY over hypotenuse, which is 100. And we're going to say CY equals sine 70 times 100. Now, because we dealt with this as positive going up and that's positive, this has to be negative. So we're going to come in here and we're going to write a negative, or plus a negative, sine 70 times 100. Okay, so what that is basically telling us is if we take our AX, our BX, and our CX and we add them together, that will give us our RX. Okay, so we have AX, BX, and CX giving us our RX, and then we have our AY plus BY plus a negative CY, or minus CY, is going to give us our RY. Okay, now, once we know that, and we can find this value and this value, then we can set that up and we can say this squared plus this squared equals that squared. So we're going to say Rx squared plus Ry squared equals R squared, which is basically following the Pythagorean theorem. And then once we know that, that will give us our magnitude. So we can write this R equals the square root of Rx squared plus Ry squared. Just taking the square root. That will give us the magnitude. And then also, guys, once we get to this point, what we're going to be looking for is this was our starting point. And if we have this as our Rx and this is our Ry, we can find this theta. And that will give us the direction. We will not only have the magnitude of the resultant vector, but we'll also have the direction. And how we would go about that, since I don't have the calculator, and this will have to calculate using the calculator, we can use opposite. Let's see, we're going opposite to that angle and adjacent. So we're going to use the trig function tangent. So tangent equals opposite over adjacent. So we're going to have Rx over Ry. Okay? Now, all right, so where we left off, guys, when I quit to do some calculations, is we had set up AX plus BX plus CX. I came in and did the calculations with my calculator, cosine 35 times 50, came up with these numbers, and I added them together. So my Rx is equal to my AX plus BX plus CX, which comes out to be 98.65. So this Rx right here is equal to 98.65. Now we also came down in our Ry section. We set up our AY plus BY plus CY, and you'll notice that the CY is negative, the AY was positive, the BY was positive, and when we do that, we come up with a negative 56.74 meters. So when we come over here, basically what that's saying is this is 56.74 negative going in this direction downward. And that vector component come up with our resultant right there. So with that being said, if we know these two components, we can use the Pythagorean theorem, rx squared plus ry squared to get r squared. So I plugged in those numbers right there and there to come up with our magnitude of our resultant vector. And so guys, that's going to be equals 113.8 meters right there. And then once I knew that, I simply came in and we knew our rx and we knew our y. So we set up opposite and adjacent. So we set up our tangent trig function. And we said tangent theta is rx over ry. Plugged in our rx is 98.65 right there. And our ry is 56.74. Once we did that, I was able to use the inverse tangent function to solve for my theta. So it came out to be 60.1 degrees. So basically what that's saying is this is 60.1 degrees from here to here. And so to get our final answer for our resultant vector of adding A plus B plus C together, we're coming up with a magnitude of 113.8 meters and a direction of 60.1 degrees. And if we look, guys, we're moving from the south direction towards the east, so it would be 60.1 degrees east of south.